Hi everyone, welcome back to my channel Chai and JRF by Eva. So in this video today we are going to learn about the concept of logical equivalent statements. So what are they? In order to understand the concept of logical equivalent statements, we need to go through certain basic concepts. So let's go through such concepts. So, in order to understand what exactly are the logical equivalent statements, these are the statements that have the same meanings, right? For example, if I say no humans are animals, right? So it will be so its logical equivalent will be no animals are humans, right? So if we say in either way, the meaning will remain the same. That is the concept of logical equivalence. So now moving ahead with the concept of propositions. So what exactly the propositions are? So propositions are generally statements, right? So what exactly are the statements? So statements are a group of words that represent certain thoughts in our day-to-day lives, right? So for the sake of understanding the logical reasoning concepts, the statements might be weird. They might not be true in reality as well. For example, when we say all dogs are cows, that is not true in real life, right? So that's why we can say that certain statements are not true and valid in real life, right? So now let us talk about the concept of proposition in depth. So here we have this proposition, as I already told you about, that proposition is simply a sentence, right? So when are we going to call our propositions a premises, right? So we are going to call our propositions a premises only when it will conclude towards something. Moving ahead with the type of categorical propositions that we have all, that is represented by A, then we have no, that is represented by E, then we have I, which represents some, then we have O, which represents some node. Also, on the other hand, if we look at these quadrants, if we go towards the downward sides, we are talking about the quantity, right? So when we are going from this positive quantity, so all means it will include all of the elements in that entire set. When we talk about sum, it means that it will include few of the elements from that entire set, right? On the other hand, same goes with the negative propositions, right? So here we have no and some not. So towards downside, the quantity will get reduced, right? And on the other hand, when we talk about the quality, so quality is all about what are we talking in general sense, right? For example, we are including all or no, so which means that they are at the extremes. Either we have all the elements in it or we have none, right? When we talk about in terms of quality, we are talking about all and no, some and some not. These will represent our quality of our proposition. And moving ahead with the part of the argument, what exactly is an argument? So argument is generally argument that has certain premises in it, and on the basis of premises we have a conclusion. When we have a conclusion, we can say that we have an argument, right? So it will be logically considered as an argument. So I hope this is clear to you. What is the concept of basic categorical propositions, how we define its quality and its quantity, right? And let us move ahead with our other sentences. Let us talk about what are inferences. So inferences are nothing but your conclusions that you draw from certain statements, right? So we have certain types of inferences in our logical reasoning, that is immediate inference and mediate inference. So in immediate inferences, what is going to happen is we have only one premise, right? In mediate inferences, we have more than one premises. Let's have a look at the examples in order to understand the type of inferences that we have. So here are the examples for inferences, the instance that I was talking to you about, the immediate inference, right? In such inferences, we only need one premises to generate a conclusion, right? So you can see like here is only one premises is given, that is all dogs are cows. I know it is not practically valid, but yes, in order to understand the concept of logical reasoning, that's why we are learning weird concepts. So yes, that's why we can say that coming back to the topic, so that's only the one premises that we are needing right now. On the basis of mediate inferences, right? So mediate inferences, it is going to require more than 2 to 3 premises, right? So when it will have generally 2 to 3 premises, and on the basis of that we will have a certain conclusion, right? So it will be formed using syllogisms, right? You know the concept of syllogism, it's a different concept, but in today's video we will be focusing on immediate inferences, right? So immediate inferences, it is also termed as logical equivalent statements. So because we are going to change the statements, but the meaning will remain the same. So for example, let's talk about this mediate inference. What is happening on the basis of syllogism? We can draw this syllogism: all dogs are cows, right? So all dogs are cows, all cows are animals. So we can say that some animals are dogs. So that is true. So in order to come to a conclusion, we are using these two premises. That's why it is termed as mediate inferences. But for today's topic, we will be focusing on the logical equivalent statements and immediate inferences, or immediate conclusions that is drawn from just one premises only. So going ahead with the concept of immediate inferences types. So further we have certain types of inferences under immediate inferences, that is converse, obverse and contraposition. Now we are going to understand these concepts. UGC generally asks questions from these topics. You are being asked to convert a statement into its obverse part, or maybe it can ask you to convert into its contraposition statement or its converse position, right? Or it can simply ask just mark the option that are logically equivalent to each other. So now let us go through the concept of converse. How do we convert a statement into its converse statement, right? So the original statement, right? Let me write it here. So this is your original statement that is given to you to change it into converse form. So that is also known as convertent, right? So convertent is your original statement that you are going to convert into your converse, logical equivalent. Okay, so in order to understand this concept, for now we will ignore A here, but we will be focusing on these E and I. So now what is going to happen in this categorical type? So E stands for no, and I stand for some, and O stands for some note. I hope you remember all this, right? So now what is going to happen here? So always remember that converse is not applicable on O. So it is not applicable on O type of categorical proposition, that is your some note. So conversion, we cannot converse our statements that are of O proposition, right? We cannot convert some not type of statements into its conversion form, right? So now let us understand the basic rule. How do we convert this convertent into converse logical equivalent? So here is the statement. So let us say here is the example for no that I have taken. It is E type of proposition, that is no. For example, no apples are vegetables. What are we going to do here is we are simply going to do is our quantity and quality, right? At the very first it will remain same. Quality and quantity will remain same, right? And for apples and vegetables, what are we going to do is we are simply going to interchange our subject with predicate, right? So our answer will become no vegetables are apples. So this is your converse logical equivalent for this statement, right? Now let us try to understand these other examples. So looking at this part, E conversion, we already saw that. So now we have no. What are we going to do? We are going to keep it same. Quality and quantity, it will remain same. So no as well. So flowers will get interchanged with stones, and stone will get interchanged with flowers. Right? I hope you got this example. Moving ahead with our I type of proposition. Right? In I, same will remain. So this part will remain same, no change in quality as well as quantity. Some will remain as some. Now we are going to interchange subject with our predicate. So you can see here is our answer, converse logical equivalent. So this is the answer. So it is not valid for O. So no, we are not going to look for its O proposition, right? So now let us discuss its concept of limitation, right? Converse by limitation, what does it mean, right? In order to understand that what does it mean, what are we going to do here is, so in conversion part what is going to happen, so here we are going to change its quantity, not quality, right? What are we going to change? Its quantity, right? Not quality. So here we are changing its quantity. From all it will become to some. So this is the exception case. It will happen only for all, right? Only for a type of proposition. So you don't have to worry much about it. So the reason why are we doing this exception here, why are we using this rule of exception by conversion? Because here you can see that all men are mortals. If you know the rule of the distribution, right? So all distributes the subject, but it does not distribute our predicate, right? So we cannot say that all mortals are men. We are not sure about it, but we are sure about that all men are mortal, but it will not happen in other direction. Why? Because it is not distributed, because all does not distribute our predicate, right? In order to understand it in different and easy language, for example, if I tell you all gold rings are jewelry, right? All gold rings are jewelry, but we cannot say that all jewelry is gold rings, right? So this is how it works. So this was the example. I hope you got the concept of conversion by exception. So let have a look at it, what we did. If you are not able to get it, just rewatch the video again, so you will get the concept easily. Moving ahead with our next concept, that is related with obverse. So now here is the original statement. It is also known as overtend and obverse logical equivalent, right? So it is applicable to all types of categorical proposition, be it A, E, I, O, any of it. It is applicable to all of these, right? So now what is going to happen? What are the rules that we generally follow to make the sentence sound same or mean the same, right? So here are certain rules we have to follow in order to convert into its obversion logical equivalent statement. So what exactly is it? For example, all apples are vegetables. We are taking the same base example. So now what is happening here? So now what we are going to do is, we will keep the quantity same, right? But we are going to change its quality, right? For all we have no, right? And it will work vice versa. If we had no on the verb, so it will be changed with all, right? So this is how we are going to, in obverse, always remember that in obverse we are going to change the quality of that overtend, right? So we will be changing its quality from all to no. If I say that change its quantity, what are we going to do? Then we will be writing as all like we will be writing it as all to some. If only if the case of, if I talk about changing its quantity instead of quality, but here we are focusing on quality only. So that's why we are changing it to no, right? Your subject will remain the same as it is, but here we have certain changes for our predicate. For the predicate part, we are going to write the opposite of it. How to write opposite of it? We can simply write non in ahead of it. Don't use English language for the term opposite. For example, male hai to female, but it is not going to work like that. So you have to simply add the word known in front of predicate. It will simply define that it is opposite, right? So there is no rule for exception here to follow in case of obverse. Obverse is simple as that. You just have to keep the subject same, but you have to change the predicate using its opposite or a noun in front of the predicate. So yes, and at the end we are going to change its quality, right? But we will keep the quantity same, right? Now moving ahead with other part, that is contraposition. So right, what is going to happen in contraposition? So contraposition is applicable to A, E, O type of proposition. It will not include I type of proposition, so it is discarded already. So we are not going to use contraposition logical equivalent statement. We cannot convert it to other form for this I proposition. For others we can simply change that. So what is the rule here? So here is a rule that we are going to do is, for example, let's take a basic example that was all apples are vegetables. So now here what is going to happen? We are going to keep the quantity and quality same as it was originally. And moving ahead with the subject and predicate, what is going to happen? We are simply going to interchange our subject with predicate, and we are going to add noun in front of that, right? You have to add noun. So when we add noun, it means we are contrapositioning the subject and predicates. You know, when we say all apples are vegetables, right, it means that all the apples are vegetables, right? And we are going to make it in a other statement that is its logical equivalent. So that will be all non-vegetables are non-apple. So we are going to add noun in front of subject and in front of predicate. In order to understand the concept of contraposition while limitation, what is going to happen? So look at this E type of proposition. It states that no stones are flowers, right? So according to the basic rule, what are we going to do is no non-flowers are non-stones, right? And but this is not correct. Why? Because no is distributing both of them, so we cannot do that, right? We have to generate a certain relationship between these subjects and predicate. That's why we are saying that at least some known flowers are known stones. That's how we can say that the no stones are flowers. So there exists no relation between these. So that's why. So always remember, for the case of contraposition by limitation for E, we are going to change our quantity, right? So we will be changing our quantity, right? Here we are going to change our quantity. From no, we will go to some, and we will add a not in front of predicate. Same goes for this example. So what will be the contraposition by exception for this statement? So it will be, so let's say the statement will be no apples are vegetables. So its contraposition sub-ecological will be what? Your some non-vegetables are not non-apples. So this will be your contraposition logical equivalence for this statement. I hope you understand the concept very well. Go through the video again if you feel like you are getting stuck somewhere. Comment down your doubts and queries, and also I have given you a set of questions to practice at home. I want you to solve these questions and write its answers in the comment section. That's it for today's video. Thank you.